She's
Okay.
taken 2 tests now, specifically around subtracting and dividing integers, and she's failed them both.
Okay. So
That's
good
what we
news
got.
is the integer stuff isn't really related to the root stuff. So I can focus on the roots today, or the roots, which would be best.
Probably integers.
Probably
Because I'm
integers.
retaking a test that's all about integers tomorrow.
Okay, let's do that then. All right, so everything I'm saying is relevant so far. Okay, so there's 2 cases. Case number 1 is same sign. Okay, and what do I mean by that? Well, you already know this. Like what is 4 plus 3? You already know the answer. That's 7. But why? Why is it 7? Well, the answer is the first thing you do is you keep the sign. Okay, when they're same sign, you keep the sign. And this will make more sense if we do a more complicated example. And then the second thing you do is you add the numbers without the sign. Okay, and it'll make more sense here when we do another one. So let's say it's like -5 plus -4. Do you agree that these are both same sign? -5, -4, they're both negative. Do you agree with that?
Yep.
Okay, so you keep the sign. So the answer is, well, it's a negative, right? And then you add the numbers without the sign. So and it doesn't matter to me whether you do this, but you look at them as 5 and 4 without the sign, and you're like, all right, 5 plus 4 is 9, and the answer is -9. So our goal is for you to be able to do this, give me the answer without this, but for now you may have to do this. There's 2 steps. When they're same sign, you keep the sign and you add the numbers without the sign. Now, another example here, because it comes in a couple of variations. Let's say it's a -2 minus 6, okay? These are actually same sign. Now you might disagree. You might say, well, hey, isn't that +6 and you're subtracting? Yes, it is. It can also be written this way, where you change that subtraction into addition of a negative. Have you been seeing that in the classroom?
Yeah, our teacher wants us to do that, but I just really don't get that.
Okay. Ooh, well, okay, well, so I don't like doing this, but we may just have to accept that right now as having to do that. We can get a more explanation, but right now we're kind of just, we want to do and not necessarily know why, which we can get to. Like, I don't want you to think that that will never be the case, but when we're kind of catching up, it's to do that. Now, the best explanation I can give you at this point is that it's better to add than to subtract. It's just more, we like it adding things. We don't like subtracting. Even though you're adding a negative, it's preferred to subtracting. So these are same sign. Do you agree that these are both negative here?
Yes.
And maybe it's easier to see it this way than this way, because you could say, well, it's negative and then that's positive, but you're subtracting. It is, but if you make the adjustment, they're both negative. So you keep the sign. I mean, it's negative, and then you treat the numbers as if they don't have signs. You say, okay, it's 2 and 6. So it's 2 plus 6, like that. Okay. And then you add the numbers. So it ends up being -8. All right. So all 3 of these examples are all same sign. So what I'm gonna do is give you a couple of problems here to try, and you're gonna give me the answers. Okay. Is that fair?
Yeah.
All right. So let's do -8 minus 2, -6. Let me get all these in here before you give me the answers. All right. So whenever you're ready, if you could work through these and give me the
For the first one you wrote down, it's -10.
okay.
The second one you wrote down is -12.
Okay.
Third one is 8.
Okay.
And then the fourth one is -11.
Good. Okay. So there's 2 types of problems that we're going to see. Same sign, which we've just done, and then opposite sign. Opposite sign is 1 positive and 1 negative. And these are there's more examples to give of these, but your first sort of fork when you're learning these, when you're kind of distinguishing, it's like same sign or opposite sign. And we do this all the time. Like, do you play any sports? Do you do any extracurricular activities?
I play soccer.
You play soccer. Okay. So when you're on defense, you do one thing, and when you're on offense, you do another thing. Is that true?
Yeah.
And you have to know that. Like your coach doesn't tell you like, hey, we're defense. Hey, you have to know that. So kind of like that. You have to then be able to distinguish. So let's do a really simple example. I mean, it seems so ridiculous. You're like, why would we even do this? What is 9 minus 7? What does that become? Sorry?
Yeah.
2. Now, how did we do that? First thing that you do is you determine the sign. And you're like, why do I need to determine the sign? I already know the answer. Because we want to learn how to do this generally. So to determine the sign, you have to determine, or determine the sign. You have to figure out which is further from zero. Further from zero. Sorry, the handwriting's not very good. And we're looking at, and imagine these are on a number line. Okay, here's 0. I'll say that's 9. I'm sorry. That's 9, and there's -7. So which is further from 0?
The 9.
The 9. So we know the answer is positive. Okay, so that tells you whether the answer is positive or negative. Okay. The second thing you do is you take the larger and subtract the smaller without the signs. Meaning, like in this case, it's silly, but as you already know the answer, is positive. But then you'd say to yourself, well, it's really 9 is the larger one, 7 is the smaller one. I subtract them and I still get 2. Okay. But the recipe over here, the algorithm, is important. Okay. You first determine the side by figuring out which is further from 0. That tells you whether it's positive or negative. Then you take the larger number and subtract the smaller without the sign. So you don't look at them as if they're positive or negative anymore. So let's look at an example where this makes more sense. Let's say it's 2 minus 8. Okay, and this is kind of the example that could be written this way: 2 plus -8. Okay.
That would be -6.
So let's talk about why let's go through the progressions though. Which is further from 0, 2 or -8?
-8.
-8. So you know the answer is negative. Then you look at the numbers without signs. So you say, okay, it's 2 and 8. You take the larger and subtract the smaller. And I'm not saying you did anything wrong. I'm just showing you how you did this, and you get -6. Okay. Now we
Okay.
want you to, like, the goal is to do this without any of this in between, but it is certainly okay to do this. Okay. Now let's try another one here. -3 plus 4. Okay. -3 plus 4. Which is further from 0?
4.
4. So we know the answer is positive. Then you take the numbers without the signs, larger subtract the smaller, which is 1. Let's try another one here. Okay, what does this become?
This becomes 10 plus. Yeah, it's going to be a +4.
+4. Good. Okay. So let me give you a couple examples here to try on your own. Let me just get them all up on the screen before you you give me the answers. All right, so go ahead and work these out for me, please.
The first one is -4.
Okay.
The second one is also -4.
Good.
The third one is 4.
Okay.
And then the fourth one.
Okay. So the challenge here is not necessarily like, so let me just go back scrolling up the notes. Sorry for all the scrolling, it's bad. Is case 1, we just did case 1, and then these are all case 2. And that's not really the issue. The issue is when I mix them up. When I give you, and you have to decide here, are you going same sign or opposite sign? Okay. So let me give you 4 problems here to see where you're at. So go ahead and work the 4 out for me, please.
-4.
Go ahead and work them all out before you give me the answers, if you don't mind. And you can write them down or just hold them on. Each paper.
All right. -4.
Okay.
-15. -3.
For this one here.
Yeah.
Okay, go ahead and look at that one more time, please. Are these same sign or opposite in sign?
That would be -15.
It's -15, yeah.
And then that would be -5. Right. That would be 1.
That would be 1. So kind of what I was just saying, like, it's like, as soon as you get to the mixture problems, the ones where I'm not telling you, oh, they're both same sign or they're both opposite sign, that's where you run into a little bit of difficulty. So let's do a few more of these. Let's see if you can get them down. So really the big thing here is to, are they same sign or opposite sign, and then go. So let's take a look here. All right, go ahead and try these, please.
First one is -3.
Go ahead and work through all of them for me, please.
I've worked through all of them.
Okay, so -3, and then,
-13.
okay, going.
8.
I'm sorry, what was this one?
-8.
Okay,
Yeah.
keep going.
And then 2.
Good. Okay, so a couple of like variations, things that you might see here, because sometimes you see problems with sometimes you see a double negative. So we're gonna look at those next. So if I give you something like this, a -6 minus a -7, the double negative here becomes a plus. So this becomes -6 plus 7 on as a result. Have you seen that before in class?
No.
Okay, okay, so this is new.
Yeah.
All right. Well, did you see it like that on your test or quiz?
No, I don't think it'll be on there.
Okay,
Yeah.
so maybe we shouldn't do these. Okay. Well, so the next type of problem you might see is sometimes they put these numbers in parentheses. It'll be like -7 minus 6, like this. Okay. And sometimes you see these problems in parentheses. Parentheses are not needed at this point, so you can just drop them. So what would this become?
-13.
All right. So how about what if it was -8 in parentheses plus -6? So the way to work -14, good. Okay. Now, did you get any problems where there were more than 2 numbers that you're adding and subtracting?
Yes.
So you might have seen something like 6 minus 7 minus 1, like that.
Yeah.
Okay. Could you try working that out? And the way to work this out is to go left to right.
Zero.
What is 6 minus 7?
That would be 1. Wait, that would be -1.
Okay, and then you bring the next stuff down. Are they same sign or opposite sign?
Negative.
They're same sign, so your answer is negative, and then you add the 2 numbers together. So -2.
2.
Okay. But see how easy it is to put the wrong answer? You've said 0. You've got to work it out this way. So let's try another one here. Give this a try for me, please.
-4.
For what part? The whole thing or?
The whole thing.
Okay, so the first two is minus two becomes what number?
-4.
Okay, -4.
That would be 0.
Try again, they're same sign, so the answer is negative.
-8.
Yes. So what do you think is happening here? Because this is two problems in a row. You've given me the wrong answer. I don't know. I can't see what you're writing down, so I'm not sure. Because you were doing all these other ones really well, but as soon as we got to three numbers, like something happened, and maybe you're not doing this. That's sort of like, the Amazon smile there. Like you have to do them in pieces. You can't just quickly do it.
It's
You know.
because I keep thinking that's a subtraction sign, not a negative.
Okay. So yeah, we'll do a few more here. I'm just gonna put up my kind of one of my sayings, which is fast and wrong is still wrong. We don't want to be fast. We want to be right. Slow and right is way better. So let's try a few more here. 5 minus 4 minus 6.
So the question, are these negative numbers or positive?
Well, it's so what you got to decide here if you're going to change this into plus negative. But it shouldn't really matter because you're going to do the first two numbers first. You work these left to right. So I'm okay if you do subtraction or if you want to add the negative. You have to decide as the math student. You have to decide what you're going to be committed to. There's a reason your teacher wants you to change this to this. I mean, that is preferred, but you get a decision on this.
-5.
As what? Your final
Um,
answer? Okay.
yeah.
Yes, very good. Okay. So let's keep going here. Okay, go ahead and give this a try.
-6.
Perfect. Okay, so you're getting it down here. So like here's some things that could throw this off. 7 minus 2 minus or plus -5, something like this. Let's try that. It's a little different, but again,
Yeah.
the parentheses aren't really needed. They're just there to distract.
0.
Yes. All right. Perfect. Okay, so we're kind of halfway through the lesson-ish. Lessons are 50 minutes. So I feel like you've got this down. Do you have any problems though from your test or quiz to help us kind of navigate this?
I don't have the actual quiz with me, but what I do know is she let me look at the quiz when I finished Instagram.
Do you remember any problems from it?
No. But I just know I missed all the divisions.
Okay. Well, let me quickly look for a quiz on integers. See if I can find something that maybe I'm not thinking about. Did you do anything with absolute value or not?
We did do stuff.
And was that on your quiz or not?
No, it was
Okay. It's interesting. They're kind of all over the place. And you sure you didn't do this double negative thing we were talking about?
yes. I'm sure
Okay.
we
I'm only asking, how about multiplying and dividing integers? Did you have that?
yes. That's what
Okay,
I'm
so
saying.
we should talk about that next. So when you multiply integers, you have two cases. Give me just a moment. So there's two cases. There's same sign, which is when you have a positive number times a positive number, you get a positive number. And you already know that, like 4 times 5 is 20.
Yeah.
Same sign though could be they're both negative. That means the result though is positive. -3 times -6 is a positive. Okay, that's kind of that makes sense. And then there's opposite in sign. Okay, that's where you have one positive and one negative and one positive. So that's a negative and a negative. So when they're opposite in sign, your answer is negative. When they're same sign, your answer is positive.
Okay.
Okay. Now this is for multiplication, but it is also true for division. Okay, so it's not just multiplying integers, it's also dividing integers. You get the same result here. So if they're same sign, it's positive. If they're opposite in sign, the answer is
Negative.
negative. Okay, so let me do 3 problems here for you, and then I'll have you do a couple. All right, so -5 times -11. I guess that's a negative. It doesn't look weird. These are both negative. They're same sign, which means the answer is positive. Okay. And there's no partial credit on these. It's either right or wrong. I mean, it's literally that important that you get the right sign. The right sign can be the difference between crashing the spaceship or landing. It's really that important. Division here. So the top one is negative, the bottom one is positive. So when nothing is written, it's positive. You probably have figured that out. Okay. So that means the answer here is -5. This first one is positive, second one is negative. Positive times a negative is negative. They're opposite in sign. There's your answer. Any questions on that before I give you some to try here?
No.
Okay. You have to know these rules, and these rules are different than adding and subtracting. So you'll notice that there's a same sign rule for adding and subtracting, opposite sign rule for adding and subtracting. They're not the same as multiplying and dividing. So be very careful not to confuse the two, because you will see both answers if there's like a multiple choice situation. Okay. Tell me what you got here. Go ahead and work these out. Give me your answers when you're all done.
-35.
Okay.
-3.
Okay.
-7.
So this last one, are you multiplying or dividing?
Oh, multiplying. So that would be -28.
Let me give you a couple more here to try. There we go.
-3.
For the first one. Okay, good.
18.
Okay, good.
2.
2. All right, very good. Let me give you a couple more here. Then we can move on to something else.
Negative 48.
Okay.
65.
Good.
Negative 15.
Try again. That last one is maybe one that you're not used to seeing. You can always use long division.
Oh, negative 13.
Yeah, very good, very good. Okay. So I think you've got it all down. Were you doing anything else like order of operations? Like what else were you guys kind of working on if you remember?
We were doing square roots, which I'm struggling
Okay. How about any like story problems with integers?
on. No story problems with integers.
Okay. All right. So we can move to roots now, unless you feel like you need more practice with adding and subtracting integers.
I think I'm pretty good with it.
Okay, definitely be good to practice the ones like we put into this, if you have time later on. So let me pull up, we're gonna get to your practice, but before we do that, there are a few, there's on my website, there's some reference sheets and I'll drop a link to that on there, but you need to know certain square roots. Like you have to know, these. Let me get this up here. I'm just grabbing a snip here. Sometimes it takes a little while. So like you need to know all of these square roots. And then I mean, you can go a bunch further. It's kind of like, I don't know where to tell you to stop. You need to know some of these. Did your teacher tell you up to what number you need to know?
No, she did not.
So in that case, like more is better. Like if you think you need to know up to 12, you learn up to 15. That's really important. So on my website here, drop a link to that. I always have some reference sheets available. You can also find these on the internet. They're really useful for like having out next to you when you're looking up stuff, especially until you know them. Like you'll eventually know all these without without having to look. So let me see if I can get this one. There it is. Copy link. All right, dropping that in the chat. Look at that later if you want. So maybe I just have this in mind, or maybe open up that. So let me pull up some problems from your um, your practice test here. Sorry, I just got a lot of things I'm clicking. All right, so the most basic problem is, well, yes, I guess all right, so the most basic problem would be something like one on from this list, like the square root of 144. Okay, and you know that is 12 from this list, but that doesn't look like what they're testing. They're testing stuff like this, like what is the square root of 1.44?
Yeah.
That's more the question. You're like, well, how do I even do that? Well, there's a couple of ways to do this. I really wish I knew the way they're showing you in class. One way is to recognize that for every 2 decimal places, that means you move your answer 1 decimal place. And I don't know if that's the way they said it in class.
Yeah.
Is that the way they said it? Because I don't want to like go off on a tangent if that's not. So so in this one, like you look at it as the square root of 144, which is 12, but you move the decimal 1 place to the left. So the answer is 1.2, like that.
Yes.
Is that okay?
Yeah.
Okay, so like what if I asked you for the square root of 36? You would know that that is
3 point. Yeah.
so just square root of 36. We'll get to this one down here. Square root of 36 is a known one. You'd go to your table here. What's the square root of 36?
6.
6. Okay. Now, if I ask you the square root of 0.36, okay, what I'm hoping that you'll do is remember this. That for the next one, I won't give this to you. You have to remember this. So now that means you move the decimal. So there's 2 decimal places.
Mhm.
You move it 1 place to the left. So what is the answer?
That would be 6/10.
Yeah, 0.6 or 6/10. Good. Okay. So let's say it's the square root of 81.
9.
I'm sorry, 0.81. Sorry, not 81, 0.81. What would that become?
9/10.
0.9. Good. Okay. Now, where this could get, I guess, more complicated, but it's hard to tell. Your instructor actually has you go up to this. Where it becomes more complicated is like, what if it's the square root of like 2.89? You have to go off to your and remember, what's the square root of 289? Are you allowed to use the calculator, or it's all by hand?
Sometimes we are. Normally, it's all by hand.
Okay. So I guess the answer is you need to know all of these. So spend some time with note cards or Quizlet, something like that. All right. So what would the square root of 2.89 be if the square root of 289 is 17?
1.7.
Very good. All right. Now there's a couple of properties of square roots that you may need to know. The square root of a divided by b is the square root of a over the square root of b. So if I ask you for the square root of 4 over 100, this is really the square root of 4 over the square root of 100.
So
And you're
that
supposed to know all of those.
would be 2/10.
Be 2/10. Does that reduce?
And then equal 1/5.
1/5, yeah. All right, so how about the square root of 9 over 49? Could you try that one for me, please?
3/7.
Good. Now, if there's a negative in front, that negative goes with it.
10.
About square root of 16 over 25, like that.
10. And
You have an answer for me? I didn't hear it if you said
yeah,
so.
fine. 4/5.
4/5, good. All right, really good. Your instructor talks about cube roots.
I think they did it while I was absent one day because one of my problems is like 3 at the end of it, and then it's the square root of 729.
Yeah, so kind of like square roots, there's a bunch of these that you could consider knowing. And it's like, I can't tell you how many to know. I can only recommend that you learn all of them, which, I mean, I know that's not a great answer, but that is what's needed. So it looked like your instructor included up to, like, you guys on your quiz there, you were asked for the cube root of 729. So cube root of 0 is 0, cube root of 1 is 1, 8 is 2, 27 is 3, and so on here. Just looking at this list is good. If you don't know this list, like let's say you wanted the cube root of 216 and you kind of thought it was 6, you could take 6 times 6 times 6 and see if that works. See if that equals 216. That would be kind of your workaround here.
Oh, okay.
But as far as like, I mean, that your instructor can't give you something. You have to be given something on this list. like, there's not a, like, they're not gonna give you a number. And, you know, you're not gonna get something like weird that isn't on this list, I'll just say. But some of them don't look right, like 343, really, that's 7? Yeah, it's 7. You gotta be on the lookout for that.
I'm also a bit confused about some of these because
About what?
some of the cube roots are like 694 or 603 or 203.
Which problems are those on the?
They're in 1.9 S.
Yeah, so that's the next thing to get to. We're gonna do a brief introduction to that. And then we're going to probably just have to end here for today. So let me put a number line here. So let me start this number line at 0. There's 1, there's 2. Now I'm gonna spread these out. Okay, so now I'm gonna put 0 here, and imagine like there's some more room here. So that's 1, and then that's 2, like that. Okay, so just imagine like I'm just going out a little bit further here. So the square root of 1 is 1. Do you agree with that?
Yeah.
And the square root of 4 is 2.
Yep.
So the square root of 3 is somewhere in here, and the square root of 2 is somewhere in here. Do you agree with that?
Yeah.
Now, if we go out to 3, which is there's 9, square root of 9, the square root of 8 is like here, the square root of 7 is there, square root of 6 is there, and the square root of 5 is there. Now, do you see how the square root of 8 is closer to 3?
Mm-hmm.
And the square root of 5 is closer to 2?
Mm-hmm.
So when they give you a problem that you have to find, and that's where you got to go back to this list, you have to find the 2 square roots that surround it. That's why another reason why I got to know this list. Okay, so let me give you an example. Let's say I want the square root of 34. And you happen to know this list so well, let me snip it in, that you're like, hey, that's between the square root of 25 and the square root of 6. But which one is it closer to? Is it closer to 36 or is it closer to 25?
6.
Right, so the answer is that it's about 6, okay? But if I gave you the square root of 28, which one is that closer to?
That would be closer to 25.
So it'd be about 5. But what if I asked for the square root of like 31 or 30? Let's do 30. You see that's right in the middle?
5.
You're probably not going to get that. They should be really close to one or the other.
Okay.
All right. All right. So we do have to stop there for today, Brynlee. So give me just a moment here I stopped the recording.